Okay. Here we're going to do number 3. Consider the following reaction. Copper chloride reacts with potassium iodide to produce copper iodide and potassium chloride and iodide gas. So question A, when 0.56 moles of copper chloride react with 0.64 moles of potassium iodide, how many moles of iodine gas are produced or formed? Okay. So here we got to think about, we got these two ingredients here and here, and we have certain amounts of each of those things. Now, one of those amounts is going to run out first, right? So one of those things is going to run out first. Whichever one runs out first, we would call that the limiting reactant. So the limiting reactant is going to determine how much of this iodine we can produce, right? And then you'll have some leftover of the other one. So what we need to do is double check how much copper, with 0.56 moles of copper chloride, how much of this do you get? And then check, okay, with 0.64 moles of this, how much of this do you get? And compare those two numbers. So that's what we're going to do. I'll do the copper chloride in sort of this magenta color. So we have 0.56 moles of copper chloride, and we are interested in how much iodine gas we produce. The molar ratio is 2 to 1, so 2 moles of copper chloride will produce 1 mole of iodine gas. And when you crank out that number, you get, 0.28 moles of I2. Okay, so that's how much iodine you'll get with that amount of copper chloride. So let's just check, what about potassium iodide, right? What about this one? Well, we got 0.64 moles of that, potassium iodide, and the molar ratio between these two things is 4 to 1. So 4 moles of Ki will get you 1 mole of I2. So it's really just saying 0.64 divided by 4. That, I believe that's 16, so 0.16 moles of I2. Okay, so if you think about it, the potassium iodide right here is the one that's going to run out first, right? You could tell because it produces less iodine. So again, that's how we determine the limiting reactant. So this one right here is the limiting reactant. So let's just finish up with A, I suppose. How many moles of iodine are formed? Well, we can only make 1.6 moles of it, right? That's all we can make because that's the smallest amount. We're going to run out of potassium iodide after that, right? It would be great if we could make 0.28, but we don't have enough. So what's the limiting reactant? This would be the potassium iodide. Again, because you compare these amounts, and the one that makes the least must be the one that you run out of first. Logically, right? Makes sense. So for the reactant in excess, okay, so this must be, let's switch color. This must be the one that's in excess, right? You're going to have some of this copper chloride left over. How many moles are left over at the end of the reaction? There's a lot of ways you could think about this thing. A lot of ways you could go about getting the answer. What I'm going to do is I'm going to say, okay, if we have 0.64 moles of potassium iodide, how many moles of copper chloride will react with that? And then I'll just subtract just figure out how much we have left over. So that's one way to do it. That's the way I'm going to do it. And we'll do this in purple, I suppose. So if you have 0.64 moles of potassium iodide, and the molar ratio between potassium iodide, making a mess up there, and this looks like 2 to 4. So it's going to be 4 moles of potassium iodide needs 2 moles of copper chloride to mix it with. And so when you do the math, you have 0.64 times 2 divided by 4. You end up with, well, just half of 0.64, I guess. So 0.32 moles of copper chloride. Okay, so what does this mean? It means that when you, let me just erase some of this. What it means is that when you run out of potassium iodide, right, because that's a limiting reactant, you have used up 0.32 moles of copper chloride, right? So 0.32 moles of that stuff. But you had 0.56 moles to start with. So how much do you have left over? Well, it's the leftovers. You started with 0.56. minus 0.32, what's left over is 0.24 moles of it. Again, let's not overthink this stuff. This is not complicated stuff. Just think logically, right? So how many moles are left over at the end? 0.24 moles of copper chloride. And that's how we do these things. Just take it step by step. You check out if you have a certain amount of each ingredient. You figure out how much product you could get. The one that makes the least amount of product must be the thing that you run out of first. So that must be the limiting reactant. And then now that you know how much product, like the maximum amount of product you can get, you could work backwards to figure out, okay, how much of both ingredients do you need? And if you're looking for how much left over do you have, it's just a simple subtraction, right? So don't overthink these things. It's pretty straightforward.